I'll be talking about some modeling that we've been doing for the past few years of our intermodal facilities to help the business make decisions on how to expand capacity. I'll start by giving a brief overview of the railroad. I know some of those people over there on the railroad table might know who we are, but for those of you who are not familiar with us, we're the largest railroad in the U.S. We cover the western two-thirds of the United States with our network. We have come about from the product of about 400 different railroads over the past 150 or so years. We have 32,000 miles of track, 41,000 employees, 8,000 locomotives, and we've spent more than $60 billion since the year 2000 on capital investment, a large portion of which is on our intermodal facilities to expand capacity, and that's what I'll be talking about today. In terms of our business, we're kind of broken into four main groups: agriculture, coal, industrial products, and then intermodal and automotive. Auto is automobiles, trucks, vans, but the largest portion of that orange slice of the pie is intermodal. So we've moved over 5 million intermodal containers and trailers last year. Brief overview of our group. We're the Operations, Research, and Advanced Analytics group. There's about 25 of us. I lead the intermodal team. That's within that group. We have our degrees in OR, IE, stats, math, computer science. We operate basically as an internal consulting group, covering all areas of the operation, from real-time dispatching, scheduling of trains, crew planning, locomotives, intermodal, really the whole gamut. Skills, a lot of us are optimization people like myself, but we, of course, use a lot of other techniques as well as just general business consulting and programming. And in 2017, we saved the business $110 million. So with our relatively medium-sized group, we're making a lot of impact. And the reason I did that sales pitch is because we're hiring. I'm actually the recruiting manager right now, so if you're interested in working with us, let me know afterwards. So brief overview of intermodal. I'm sure many of you are quite familiar with the operation, but brief overview for the rest of you. So intermodal involves shipping containers and trailers. Containers are the boxes that come over thousands of them on a boat at a time. They don't have wheels permanently attached, whereas trailers have the wheels permanently attached to them. Think of a UPS trailer, for instance. And they move on various modes of transportation: ship, rail, and truck. We kind of break our business into two main types. International is where, let's say, it's coming over on a boat, getting unloaded at a marine terminal, which we do not operate marine terminals. It then moves on rail and then is unloaded at one of our intermodal facilities before the customer picks it up. So the orange box represents our portion of the international intermodal units trip. There's multiple versions of this, for instance, going in the opposite direction, but that's kind of the general way that works. Then there's the domestic, so think J.B. Hunt, UPS. They bring a unit to us into one of our facilities. We load it on a train. The train travels across the network, unload it at the destination, then they pick it up. Brief couple seconds of videos. So unit coming inside of our facility, goes through gates. We take high definition pictures to make sure there's no damages. It gets loaded onto a train at some point. It may take a few hours or a day before it's actually departing. It will then depart the origin facility, travel across the network, arrive at the destination facility. It'll be unloaded from the train. Then it'll sit there for maybe a few hours to days, depending on when the customer picks it up. It'll either be stacked or it'll be put on wheels, and then it'll sit in a parking lot until the customer picks it up and takes it out the gate. So when we think about capacity planning for our facilities, there's kind of three main pillars. There's what we call the production track, where the trains are being processed and unloaded and loaded by the cranes. There's, of course, the cranes, and those two combined are what we call our lift capacity, our ability to lift containers on and off the rail cars. And then there's the storage capacity. So there's kind of two main types of storage. They can be stored on wheels in a wheeled parking lot, or they can be stacked on top of each other. And so those are kind of the main ways that we've traditionally thought about the capacity of our hubs and planned for the future in terms of deciding when we need to add capacity. But as I'm sure most people in this room know, things are not so simple, and there's many other complexities to a hub, and that's kind of where we got involved in modeling all the additional things that are relevant in terms of these facilities, such as the Hostler trucks, the trucks that are internal to the facilities, driving and moving units around. The customer arrival pattern, it's by no means smooth throughout the day or week. This is just an example of what it looks like over the week at one facility. Most of the units are being brought to us or picked up from us during the normal working hours of the day, Monday through Friday. And then there's the customer dwell. How long are the customers leaving those units in our facilities before picking them up? So if they pick them up after 1 day on average versus 4 days on average, we have 4 times as much parking capacity in the first case than the latter. Then there's lots of other pieces. What is the train schedule and the variability of the arrivals of the trains? Our trains don't arrive to the minute like the airlines do, for instance. There's a lot of variability. The locomotive piece, what is the traffic mix? Containers versus trailers, what is the breakdown in terms of what that process or what that hub is processing? The international domestic breakdown priorities, so there's different priorities for different customers and types of containers. Then there's the mainline delays. So the mainline is the network that I showed you on that first slide. So when the hub is ready to depart a train, there might be congestion on the main. They might not be able to depart at the time that they want to. That impacts the hub. The hub impacts the main line, vice versa. And then there's the planning processes and systems in the facilities, which today are very manual. A lot of the decisions on which train to process at what point in time, which cranes should be working on which tracks, that's kind of a manual decision, but we're working on parallel projects to make a more sophisticated system that automates a lot of those decisions. So we're thinking, as part of our model, we're modeling both current day decision makings and the inefficiencies that exist, as well as what will things look like in the future when we have a more sophisticated operating system in our hub. That's kind of a segue as to why we chose AnyLogic. So we started this modeling in 2015. We kind of compared against some of the different softwares, and AnyLogic was a clear winner for us because it's just so flexible and it's Java-based. We have a lot of interns that we bring on board, and they are software developers. They don't know simulation, but they do know Java, so they're able to hit the ground running and add a lot of value on our project because they know how to program. And then also we're able to use the model as a test bed for algorithms that we actually can roll out into our production system in the real world. So the modeling process kind of at a high level looks like this. So we go, when we're asked to model a new facility, so the business kind of comes to us and they say, hey, there's this facility, they're nearing their capacity, we need to add capacity, how do we do it? So what we do is we go understand the current operation either through data analysis and field visits. We make updates to our model. Our model is, for the most part, developed at this point, and each new facility that we model, there's maybe 5% of the work is new stuff that we have to add in because we're seeing new things at a facility that we haven't seen thus far. So we update the model, then we calibrate and validate things by running the historical volumes through the model and making sure that the model is reflecting reality. So then we work with the business and various contractors that are civil engineering firms, facility design firms that help us design potential ways that we can expand the facility given the footprint and the way the facility is currently laid out. Do we add tracks over here? Do we add tracks in another place? What types of cranes, what sizes do we want to go with? So we work with those, and then we model the potential future volumes with these new different layouts and compare the performance of them, and then it's an iterative process until we finally come to a conclusion on how we want to actually expand this facility. So here's an illustration of our network. You can see the size of the nodes on this network. We have about 26 facilities, so the size of the circle for each one represents the amount of volume that they're handling each year. So you can see a lot of our larger facilities are in Southern California or in Chicago. And then there's also a large one in Fort Worth, Texas, right near our headquarters called Alliance that I'll touch on briefly at the very end. So in 2015, when we started our modeling efforts, we were focused on our Corwith facility, which is, at that point in time, was our third largest facility. They process almost 1 million containers a year. And then once we completed that analysis, and on the remaining slides, I'll be talking about some of the details on these different facilities. But after we finished Corwith, we then moved to Southern California, where we have these 2 hubs that are right next to each other. Hobart being the much larger one. It's actually the largest facility we have, processing over 1 million units a year. So I'll talk about that, and then I'll touch briefly on Alliance, which is the facility that we're working on modeling right now. So when we got involved with modeling Corwith, the main goal was we want to increase our annual lift capacity. So they knew that it was track and cranes that needed to be added, and then they weren't quite sure if we needed to add storage as well. So that was kind of our main objective. There's a lot more details that I obviously won't have time to get into, but at a high level, that's what we were striving for. And so the key challenge was that the facility's landlocked, so that facility is near downtown Chicago, so we cannot expand the footprint. It's surrounded by businesses and neighborhoods. So we must do one of the following. So we either have to, what we call densify the production tracks, where we're adding production tracks in between existing ones and then putting larger cranes underneath or over above them that cover multiple tracks. Or we need to convert some of the other area in the facility into production tracks. And so that's kind of the main goal of our model. So one way of doing this expansion then is adding what we call standard rubber tire gantry cranes that are about 40 feet wide, maybe a little taller than this building or this roof in this room, and the tracks are about 40 feet apart. And the advantage here is that these cranes are very nimble. You can quickly swarm them to the same track, like the crane on the left track could move to the right track, and so they can swarm the volume to process things very quickly. But the disadvantage is that you get fewer tracks than if you do something like this, where you have these large wide-span cranes that are probably as wide as this room and 2 times as tall, which can cover many tracks, but then the disadvantage here is it's not as efficient of an operation, at least not yet. And then we were looking at a third version, which was a kind of a new concept of what's called a cantilevered rubber tire gantry crane. So this is a crane that's kind of a hybrid between the two. It's not as large as the wide span, but it's larger than the smaller standard RTG. It can span multiple tracks, and then it does have rubber tires, so it is able to move from this set of 3 tracks to some other set of 3 tracks in the facility. So just some quick clips from our modeling. This shows a train arriving and then being what we call shoved into the production tracks. And then this next clip shows one of those smaller 40-foot RTG cranes that's going to unload this box and give it to this trucker. One key point to get across here is that this trucker is waiting for the crane to serve him the box, and that's one way that we can operate. Another way we can operate is what you'll see here, where the truck places the unit next to the track and then leaves. Here, this crane is switching the tracks because, again, it's one of those cranes on rubber tires that can move around. So the crane eventually reaches the box, loads it onto the rail car, and then some truck, doesn't have to be necessarily the same one that brought the unit, can come back and clear that chassis later. So we modeled the different possible, we have algorithms within our model that are making decisions as to what is the right thing to do for each one of these different moves at the given point in time based on the hub's status. This is a video of the wide span cranes that I didn't get a chance to talk about, so I'll just skip to this one. So this is those CRTG cranes that are spanning the 3 tracks that can do some stacking underneath. And this is a 2D view of that same model that we were just looking at, where we have numerous metrics that we're looking at: the track utilization, the arrival performance of inbounds. Are they being delayed because the hub's not ready for them? The outbound, are we loading the trains on time or are they delayed? Inventory, just numerous metrics, which really this is only a small slice of them, because most of the analysis that we do is not done watching the model. It's more after we dump the results into the database and then do analysis afterwards. So kind of the key result from this modeling effort at that Corwith facility was that, yes, this new type of hybrid crane that we were exploring does in fact give us the best combination of additional track and the operational speed and flexibility that we want. So this is a picture of that crane. It's kind of the first one of its type. I was actually up there in Chicago last week checking them out. Okay, so then after that modeling that we did in 2015, we moved to Southern California where we had various facilities. And this part of the conversation, I'll just talk about the largest facility on our network. This is our Hobart facility. And so here we wanted to add capacity. We weren't quite sure what the bottlenecks were, so we wanted to determine what they were and then figure out how we can mitigate that. So some of the key challenges here are it's again a landlocked facility. It's just surrounded by commercial enterprises. And then they have 20 plus trains a day, and they're all coming in and out of the east end of the facility because this facility is on the west coast. And then there's a lot of truck traffic congestion in the facility already. So pumping more volume through that facility is only going to make that worse. So how can we actually manage that? And then they're already nearing their storage capacity. So this shows a 4-week period of the inventory of units in the facility against the total capacity to store them. And every Monday, they're basically running out of space because on the weekends, customers are not picking those units up. We're unloading all day, filling up the inventory, and it's not until Monday morning when the truckers are coming to pull them out of our facility. So here's a video from one of the different ways we explored in terms of how to expand this facility, and it was one of those wide span options that I mentioned earlier. So today they just have all the small cranes, but here in the video we're exploring the big wide span cranes, along with something that's new to us, diagonal parking underneath the arm of the crane, which was something that we actually found worked well for this facility in terms of how much space we had and some of the additional flexibility that the diagonal parking can provide. This is a heat map that we implemented to model the congestion and help us understand where are the pinch points in the facility and think through ways to actually manage that. So lots and lots of results. I'll just talk about some of the big ones here. So we found that we could add significant capacity to this facility, but it's not as simple as the first facility where we just need to add some cranes and some tracks. We need to add some tracks, we need to add some cranes, actually several types of cranes, and then we have to improve the efficiency of the operation through various optimization techniques. So one of those is we need to route them through the facility based on the real-time congestion of the facility. So in today's world, can't quite implement such a thing because they're just manually deciding which route to take, but as I mentioned earlier, we're working on a parallel effort to improve the system and then be able to send them those routes that they can then follow. And then something else that we're starting to begin to explore is customer behavior. So are there things that we can do to smooth the volume over the week and over the day that will really add capacity for us without us spending capital dollars? So then moving to Fort Worth Alliance, this is the facility that's 15 minutes from our headquarters in Fort Worth. This facility has grown 20% year over year. They're dealing with 20% more volume than they were last year. And we are looking at automated technologies to expand the capacity here. So this is a type of equipment called a straddle carrier. They can be both manned or automated. A lot of the marine terminals throughout the world are already using these, but it's not something we have on our network yet. And so they can be automated, and they're kind of a crane truck hybrid where they can both lift the unit up and then they can move around wherever on their wheels. And so we are just now starting to develop a model that's kind of outside of our main model right now to work through the routing logic, the deadlock, all the different pieces that we need to model this type of equipment accurately. And so this is in the works. Probably in about 2 months, we'll be merging it into our main model and then doing the full-scale modeling of that Alliance facility. This is just a two-dimensional view of that with the heat map. that is all I have. I'd like to say thanks to everyone that was involved in this project and is still involved. We've had about 4 of us on and off full-time OR people, 10 plus interns, various contractors that have helped us throughout the way. So thanks to everyone, and also to the development team, because I might be their #1 question asker. I have sent them so many emails, they probably are sick of me by now, but thank you.